Hello everyone, a good day to all of us. I am Eliza Aubrey Cruz and I am here to introduce our group. We are the group 4 of 3301 and we are here to present our case study that we have selected in our journal Writing Critic. The case study was entitled The Competitive Advantage Through Six Sigma in Sandcasting Industry to Improve Overall First Pass Yield. So these are the members of our group. Introducing the case study, its goal is to show how Six Sigma technique was used in a small-scale foundry company to enhance overall first-pass material yield and quality with a focus on the product and the manufacturing process. This investigation study demonstrates the Six Sigma DMAIC deployment process step-by-step technique in the foundry industry on a small scale. So the DMAIC approach of Six Sigma was emphasized all the way on how to define the problem encountered in the industry. Second one is the measure, where verification of data integrity and establishing baseline metrics happens. Analyze, validation of root cause happen. Improve process, and the last will be the control, where the sustenance of the improvement and establishing control plans occur. Thus, in this case study, the researchers made a flowchart of hybrid methodology for sandcasting. As you can see, the DMAIC approach was used and detailed out. In the next slides, define phase was emphasized. The problem of the study, such as mold rework, inventory, and other troubles are seen from the management perspective. The departments and the parameters of all these critical problems are also included. Project charter was also done by the researchers to document the goals, objectives, and the business case for the work.
Good day, I'm Hannah Sidian and I will continue the discussion regarding the article's define phase results. The study used SIPOC and it helped the team to have a clearer view on the firm's current process regarding the suppliers, process boundaries, the outputs, and the customers. Another tool used is the CTQ diagram to identify the factors contributing to the yield loss. And based on this figure, the main CTQ identified are pouring losses and melting losses, which are both process-specific, and the feeder dimension standard, which is a product-specific CTQ. This CTQ must be prioritized to improve the current process. Now, for the measure phase, the first tool utilized is a data collection plan, which acts as the framework of what are needed to be measured, the appropriate type of data, the period and sample size, as well as the data collection source and its corresponding responsibility for the current process yield measurement. Next is the format for data collection plan, which is connected on the previous slide. This specific format allowed the team to accurately measure the yield loss of the process. So with this plan and format, the data for a 4-month period was recorded for further analysis. Next tool is the normality test for the process statistical stability, and based on the results, the data is normally distributed as the p-value of 0.190 is greater than 0.05. The next tool is the X bar and R chart, which is used since the subgroup size is only 3 and there are only 10 samples. And based on these results, the process is statistically stable and under control since there are no outliers detected. Last tool used is the process capability for the baseline sigma calculation. The process is not on target since the measurements are not centered between the specification limits, and also the capability indices are all less than the accepted minimum value of 1.33. This means that the process does not meet the requirements for process yield of sandcasting. So in this table, the correlation of the calculated CP value and the sigma level is displayed. This shows that using interpolation for the CP value of 0.24 and the obtained sigma level for the current process of 2.21 is related. So with all of these results from the define and measure phase, an SOP was formulated stating that the target yield of the sandcasting process is to have an increase up to 76% within 3 months.
Good day, everyone. I am Christian Cabrera. I'm going to present the analyze space and some other parts of improve base. And in analyze space, they use the essential root causes analysis tool by means of cause and effect diagram or Ishikawa diagram, in which it's helped to identify the possible causes for low product and process yield. And also in analyze space, they use the multi-voting technique by listing options into a critical few to identify the low process yield using the activity. And here they presented the summarized shortlisted root causes that are validated using the walking process or the Gemba method, which include the supervision for the plant in the 2 to 3 weeks period, and will make in this will make a decision either validating or rejecting the process. And in figure 8, it show the validated root causes. These data are collected and make an input for improvement, and take in consideration for your low yield, showing the visual representation and added a remark to clearly understand it. For the next one is the improve phase. In this table shows the countermeasure for low yields and to improve the overall first pass yield. The key countermeasure solutions are suggested and implemented. In table 10 shows the mold rework consumes more resources of labor and time team, and the team has identified 6 process parameters which may affect the proper mixture of molding materials. The factors and their respective levers are clearly presented using Taguchi orthogonal array. In Taguchi orthogonal array, the pilot project team has decided to perform an L8 orthogonal array using the Minitab statistical software experiment, which clearly shown the result treated as a response to the experiment, which is a degree of variation when uncontrolled noise factors are presented in this system. To clearly visualize the data, it is indicated the smaller the better, where I is represented as the average and S is the standard deviation for this experiment, where it clearly visualized that or clearly shows that the binder is 10% type, the sun is selected as fresh, bentonite powder selected or interpreted as 8%, the carbon dioxide is medium, and mixing time is 10 minutes, and the sun weigh 15 buckets. That's all.
Good day, I am Paul Antonio Bilisaba, and I'm gonna continue the improve base. We have the analysis of variance. This is the last tool that was used, or also known as ANOVA, which states that there is a statistically significant relationship between the critical parameter, type of sun, carbon dioxide pressure, and sun rate. And now we have the custom product heating system design. And then lastly, for the control piece, a standard operating procedure was formulated to maintain the calculated results using the initial steps of the DMAIC method. The key lessons learned are: a strong leadership quality guides the flow of the project efficiently. And then for the conclusion, we have the benefits to the firm, process capability analysis after improvements. As you can see, the overall improvements significantly increases. And then we have the benefits of Six Sigma pilot project and its implementation. As you can see, the yield of bearing housing from before it was 58%, and then it became 76%. For the conclusions, considering that small-scale business in India seldomly use Six Sigma methodologies to optimize their process capacity and have various reduction, the application of Six Sigma tools and analysis in this case study can be deemed as good interpretation and implementation and utilization, since the appropriate statistical and graphical tools were used. And then for the findings, as a result, on this case study, the overall first pass output of the sand casting method was improved from 67% to 78.88%. The revised gating system design increases yield by 18% in the product-specific case. The process sigma level has increased from 2.21 to 3.8.